Okay, we're going to walk through doing a significance test for a proportion. Um, so usually with this, you start with some sort of real world claim. And my claim is that Boris, my political candidate for the governor of Maryland, all right, so he's going to run for the governor of Maryland, will receive 62% or more. Sorry, will receive more than. I don't want to say 62% or more. I want to say more than 62% of the vote. Okay. So, what I'm going to do here to test this is I'm going to take a simple random sample of 100 voters. Okay. So I'm going to go out into the market, grab 100 voters, right? And that's going to be my test, right? So what I need to do, like step 0 here, is to check my conditions. I am random. That's definitely there. I have an SRS. Do I make the 10% condition, right? So 100 is definitely less than 0.1 of the 6 million Marylanders, right? So I'm pretty good there. And then I have to check my large counts. So I'm saying 62%, 0.62 times 100 is going to give me 62. 0.38 times 100 gets me 38. So my assumption is that I have made the large counts condition. So my plan to take a sample of 100 voters and see if they're going to vote for Boris is a good plan. Okay? So I have to set up some testing hypotheses, right? So I make H null has to be the actual proportion is 62%. Because I am working with this more than here, I'm going to set this up so that my alternate hypothesis is going to be that. So note, my alternate hypothesis is the claim. Okay, so that works that out. Okay, so the next thing I'm going to do here is I'm going to set my significance level, and I'm going to set that at 0.05, right? So that's like kind of opposed to 95% confidence would be a 0.05 level of significance, right? And then I need an actual test statistic. Okay, so in your notes, you're going to see that the test statistic that you're going to use here is going to be how many standard deviations from this is my proposed result. Okay, so what I'm going to say here is when I did this SRS, I found that 64 of these voters, okay, are actually, what do you call it, going to vote for Boris, right? So this means that my P hat is 64 out of 100 or 0.64. Right? So my test statistic here is going to be that 0.64 minus 0.62 over the standard deviation, which I'm going to use 0.62 times 0.38 over 100. And if you work that all out, your test statistic that you're going to get here is 0.41204. Okay, so this is a z-score, right? So if I'm thinking this through, if I have a proposed proportion, an actual proportion of 0.62, right, is what I believe is the actual proportion, then the probability, so the z-score that combines to the 0.64 is this, right? So what I need is the probability of being here. Okay, so I can work that out. This is like a normal CDF from this number to like 9999. So let me actually like just bring up that calculator, right? So let's clear that out because you don't want to see that yet, right? So let's see, can I make that smaller? There we go. All right, so let's go vars second vars, right, for normal CDF. Second vars, normal CDF. And I actually have those numbers in there. The 0.41204 is my z-score, and it's a z-score, so I'm 0 to 1, which means the probability of being above this is going to be 34.0155, etc. So my p-value is going to be, what did I say it was? 34.34015. Okay, so what I need to do, okay, is to draw some conclusions here. So this is like step 4, right? Step 4. I'm running out of space here. Don't know where to put the space, but step 4 is to draw conclusions. So the conclusion here is that the alpha, my significance level, and my p-value are things that I have to relate. And my p-value at 0.34 is greater than 0.05, which is my alpha. So if p is greater than alpha, my direction here is going to be to fail to reject the null hypothesis. Okay, what does that mean? Well, my null hypothesis was that p is 0.62. So it is, I don't have enough evidence to say that that cannot be the case, right? So if I do not have enough evidence to say that the null hypothesis is not true, then I do not have enough evidence to support my claim, right? So think about what that's saying. If I had evidence to say that the null was not true, I could support my claim. But if I don't have enough evidence to say that the null is not true, so the null could be true. I'm not saying I have enough evidence to say that the proportion is 0.62. I'm saying that it could be true. Then it is possible that my claim is false. So I do not have enough evidence to support my claim. So kind of thinking about this, since p is greater than alpha, right? Since p is greater than alpha, I fail to reject the null hypothesis. My claim was embedded in the alternate hypothesis that p was more than 62%, right? But I can't reject the null hypothesis, which stated that p was 62%. So, in short, I can say that there is not convincing evidence at the 0.05 significance level that Boris has more than 62% of the vote. Now, here's the interesting thing. If I just look at my hypotheses, right? My hypothesis, my null hypothesis is here. My alternate hypothesis is here. And I look at the statistical data that I took an SRS of 100 people and I got 64. This is a sufficient, and my confidence level, my alpha, right, is 0.05, right? This is sufficient information to do this just like writ large with the calculator. So let me go grab the calculator. Let's see what happens. I'm going to go to stat. Let me clear everything out because, well, 7, 1, 2, because I know I got stuff in there, right? So I just cleared it. All right, so let's go stat tests, and then I'm going to do the 1 proportion z test. So this is a test, not the interval, right? So I'm testing against 0.62. 64 people say they're going to vote for Boris out of 100. Now, this proportion here, this is my alternate hypothesis. In my case, my alternate hypothesis, if you look, was that p was going to be greater than 0.62, right? So I'm choosing the greater than one. And I go ahead and I calculate, and lo and behold, it gives me all my answers, right? It says my z which is my test statistic, is 0.41204, which is exactly what I got earlier. The p-value is 0.34015, which is exactly what I got earlier. My p-hat is 0.64. My sample size is 100. So what do I have to do? I have to compare that p-value, the 0.34, to the alpha. If the p is bigger than the alpha, I fail to reject the null. If the p is smaller than the alpha, then I reject the null. And then I have to word this out in terms of my claim. And we're going to have plenty of practice doing this in this class, okay? So hopefully that gets you an idea of how this kind of plays out, and then we'll walk through some of this in class specifically for proportions. All right, so thank you.